to the overall large body impact hazard.
Thanks, Dal. Hi, everybody. It's about this time of day when people are starting to fall asleep, having had a big steak or whatever for lunch. I don't believe in giving terribly technical talks. I figure that talk should be more like an advert. You know, you got an advert on the TV for a movie. They show you the best bits or whatever. They don't show you the whole story. So anybody wants to talk to me about any of this stuff later on, please do. Yeah, I came from New Zealand. People are starting to fall asleep. I left my hometown of Nelson 5:10 on Saturday, and I arrived at Dulles about 5:10 on Sunday morning. Unfortunately, I also crossed the international date line, so it's about 36 hours. Somebody told me that whoever came the largest distance was going to get free beer all week. That's the only reason I'm here. I just kind of figured when I was putting in an abstract, wouldn't it be interesting to take a look and see what are the collision probabilities with the Earth for asteroids, nominally speaking, which are in bigger orbits than everything, these wonderful huge numbers of discoveries which are being made in the inner solar system. So here's, that's all the same plot. I'm just zooming in to show more detail. There's only 19 known Apollos with periods greater than 6 years, and which appear to be bigger than about 140 meters across. When I put in the abstract, I figured there was going to be lots more, but in fact, it's quite a small number. Okay, today's a special day. When people talk about, we talked about the giggle factor, it's important to tell people that some days are more unlucky than others. And they're actually in Scandinavia, they're called Tycho Brahe days, believe it or not, for the astronomer. And I'll say a bit more about Tycho and a few other things to do with history. Somebody said earlier on, history is really important in all of this sort of stuff. And actually in that NASA movie, which the administrator showed, it mentions shoulders of giants. It's important to know the context in which various things are said. In fact, the letter in which Isaac Newton wrote that is not very far from here. It's in Philadelphia. He wrote it, if I have seen further, it is by standing on ye shoulders of giants. He actually wrote that to a hunchback dwarf. That's an important thing to know. Okay, Tycho Brahe days, I think in Scandinavia they actually called him Tycho. Certain days are unlucky, it kind of links to what Gonzalo was just talking about. So there's name days in Sweden. I don't think there's anybody here from Sweden, is there? They have name days there, so they have a second birthday, and each day of the year has got a name associated with it. Gonzalo, I know, did his PhD there, but I don't think there's a name day for Gonzalo, funnily enough, in Sweden. But there's plenty for more common names for Swedes, as shown here, Harald, Gudmund, Ferdinand, and so on. And guess what? April the 29th, which is today, is Tycho Day. So it's an unlucky day. So indeed, I think you should be wearing your hard hat, contrary to what Gonzalo said. I know Tycho pretty well as a thing because I actually use this email address on my webpage rather than the usual one, which of course is duncan@duncansteel.com, which most people can guess. But on my webpage, to stop too many lunatics emailing me, I use TMA1. It's Tycho Magnetic Anomaly 1. Does everybody here know where that comes from? Thank you. Lots of people nodding. Tycho, of course, is a big newish crater on the Earth. Tycho Magnetic Anomaly 1 is in the movie 2001, made by Stanley Kubrick, written by Arthur C. Clarke. Okay, next slide. I've written a couple of books about these sorts of things back when it was a big giggle factor. In fact, I can't claim that my book, Rogue Asteroids and Doomsday Comets, published in 1995, was the first. Clark Chapman and David Morrison wrote a book before that called Cosmic Catastrophes, which covered this sort of stuff. And I mean, it was so much of a giggle, then they couldn't even dedicate a book to it. It covered things like supernovas and all the rest, solar coronal mass ejections and that sort of stuff. Anyway, Clark, Arthur C. Clarke, not Clark Chapman, contributed the foreword for this one and the afterword to this one. This one was published by Reader's Digest, very reputable publisher in the year 2000. What's Arthur C. Clarke got to do with this? Well, I hope you all know. That's Arthur with a dinosaur. Arthur's been dead now for about a dozen years. So I can actually had a good sense of humor, so you wouldn't mind my caption here at all. But the Space Guard survey, which we've been hearing about, actually is named as such for a chapter, initial chapter in this book, in which he wrote, "So Began Project Space Guard," rendezvous with Rama. And something we've seen already today is this particular picture of Oumuamua. And in fact, the spacecraft, the alien spacecraft, which Clark imagined in this book, which is shown here, was indeed a long cylinder. And so people have already pointed out the similarity with that interstellar asteroid. You could say, by the way, in passing, how the hell can you do any astronomy in New Zealand, given that the Maori name is Aotearoa, which means land of a long white cloud. I actually did my PhD there, although I'm British originally. I did my PhD there, built a radar with which we detected, in the end, interstellar meteors, published in Nature in 1996. And I think Peter Brown at University of Western Ontario has picked up some since then. So this wasn't the first interstellar object to actually be detected in the inner solar system. There was smaller ones and lots of them previous to that. Okay, so that gave birth to, as it were, the Space Guard Survey. I remember when we were working on this, David and Clark and other people, if I remember right, it was Larry Niven and Jerry Pornell's book, Lucifer's Hammer, which was in there. And I said, no, rendezvous with Rama, we got to call it Space Guard. I did have an ulterior motive. I already had a company in Australia called Space Guard. And I can prove as it's such that this was predating Space Guard Survey, because you'll see we've got a phone number and a fax and no email address, no internet site, any of that sort of stuff. So that was long, long ago. Okay, I better talk about a bit of science, I guess. I like pulling people's tails, as everybody will tell you. Whoops, I've gone back. I want to go forward. I like pulling people's tails, that is pointing out things which maybe aren't completely thought through or assumptions we make. And what I've been hearing today is similar statements to this, which I found in the media, somebody being quoted on a few weeks ago, no names, no pack drills, but says this sort of thing. We have mapped the orbits of about 90% of the dinosaur killers. My father's from the East End of London, so he's a Cockney, and in Cockney rhyming slang, they would say, you're telling porcupines. It's a little bit of a fib. I know what it's meant. Everybody here knows what it means. You know, we've found, thankfully, a whole lot of these things, and a lot of the risk has been retired. However, in terms of dinosaur killers, we've only found a tiny fraction, because most of them are in these gigantic orbits, and we ain't going to find them on a 20-year or 50-year or 100-year timescale. And that's the truth. And all I was really interested in putting together a few graphs for this paper is, well, okay, how about at least the asteroids in bigger orbits? Can we say anything about those? And I was actually surprised to find that there's comparatively few of them, as I'll show in just a little while. I'd expected there to be more. In 1991, when we began the first survey in Australia, we found an object called 1991 DA, then 5335 Damocles. Damocles, as in the sword of Damocles, it is in a big orbit. It is an asteroid, apparently, and it has a perihelion of about 1.5 AU. And then I kind of thought, well, that means that, you know, surely there must be lots of these things. We just haven't found very many yet. And that hasn't turned out to be the case. Damocles is actually rather big, something like 10, 15 kilometers across. But if we take a look at what we now know, and I did this on April the 1st, there was almost 10,000 known out to Mag 30. There was about another 60, fainter than that, so even smaller than that. And contributing numbers of Apollos, I put in red numbers here, and here is the average collision probability down to different limiting magnitudes. So add it, let's see, 21.5 Al is 140 meters, is that right? More or less. So there's about 2,500. So we've statistically got a reasonably good idea for the collision probability, no big surprises there. However, how about the ones which are in bigger orbits? Ones we don't get very many chances to find. So here I've put in the black numbers all the way down to Mag 30, so only a few meters across. And the red numbers are for sizes 140 meters and bigger. It's a very small number. And again, I was surprised. We've only got one out at above 20 years. You only one at above 10 years. So a very small number. What does that mean? Obviously, statistically, you can't do very much, but this is what I get, the sort of curve, if I just use that number. So small numbers, only 66 above 5 years, 19 above 6 years, 7 above 7 years, and so on. And then this is upwards trend is all due to just one object, pushing up these averages for just 2 and 3 objects. So the answer seems to be somewhere between 2 and 3 per billion asteroid orbits. So between 2 and 3 times 10 to the minus 9 per perihelion passage. And that really is, as I say here, that's the bottom line. We know of very few known asteroids with periods of about, say, 7 years, say Jupiter crossing. The mean Earth collision probability is about that. In fact, years ago, I calculated it, and other people have certainly done it for a spherical cometary source, that is the autopic cloud, and an assumed perihelion distance. It comes out to be 2.2 times 10 to the minus 9. In fact, that's no different to what you get if you take a balloon, you draw a little dot on it, representing the Earth. You take the balloon to be a radius of 1 AU, and you say, what's the relative values of the area? And it can go through anywhere. You get that same value. Okay, it's as simple as that. So just to finish off, how large a fraction of the impact hazard that represents depends on what the population may be. I don't know anything about that. I'll leave that to other people. But you certainly can't know that over decadal survey timescales. Hence, the 90% is a bit of a porky pie. And I've not even mentioned the comets, really. So that's all I wanted to say. I hope I've woken you up a little bit. I'll be happy to talk about any of this sort of stuff over a beer or a coffee.
Okay, thank you. And since I was mentioned by name a couple of times there, I will take occasion to make an answer or to respond. First of all, of asteroids that actually cross the Earth's orbit, the short period asteroids, the very largest one is interestingly named Sisyphus, and it's about 6 kilometers in diameter. It's not big enough to kill a dinosaur, let alone a human. So the probability of total extinction in our lifetime, or even thousands of years or hundreds of years, is 0 from asteroids. But we know that those big things are out there, and as you point out, we haven't seen them. You know, if it has a 10,000 year period, you're not going to find them all for 10,000 years. Any other questions? Anybody else? Yeah, over here.
He's going to tell us what's going to happen in 2027 and April 2029. A real, if I could brag, maybe. Disaster, by the way, people should remember, disaster means bad stuff.
Yes.